It is now time to blend the solution between IK and FK actions. Set the view in wireframe mode, F3, if it's not in this mode already. Double-click the left clavicle to select the whole hierarchy. Hold Ctrl and add the clavicle controller and the IK controller and goal to the selection. Isolate the selection. As you recall, you have set shapes to control the IK and FK solutions, but neither is affecting the skin bones at this time. The trick is to constrain the skin bones to be oriented halfway between the IK and FK solution. After that, you need a way to control the weighting between IK and FK to favor one mode or the other. First things first, ensure all ARM controllers are transformed to 0. Select the wrist nub, named Zombie Left Wrist Bone. First, constrain its orientation to that of the IK controller. Repeat the procedure to also constrain it to the FK hand controller. Set the motion panel in rotation mode and notice the two orientation targets. The IK controller is listed first, the FK controller second. It is important to keep that order constant for the next bones in the chain. This will make it easier to establish a custom attribute that will work similarly for all bones. Select the forearm skin bone. Constrain its orientation first to the IK forearm bone, then to the FK forearm bone. Remember that you can also use the Add Orientation Target button in the motion panel. Just make sure you exit that mode before you accidentally add more targets by clicking other objects in the scene. Finally, select the shoulder skin bone and constrain its orientation to the shoulder IK bone first, and then to the shoulder FK bone. Now, when you move the IK controller, or you rotate the FK controllers, the skin bones react halfway between the two. The reaction is halfway because the weighting on the constraints are set to 50% by default. Each skin bone is weighted 50-50 between IK and FK solutions. When the IK weight is set to 100% and the FK to 0%, the IK solution is favored. When the FK weight is set to 100% and the IK to 0%, then the FK solution is favored. However, an animator shouldn't have to chase after these values in the motion panel. It is your job as a rigger to simplify that process. Therefore, you'll create one custom attribute that changes these weights for all three arm bones. By changing the custom attribute's value, the animator would be changing IK and FK weights for all three bones simultaneously. Select the IK controller and go to the Modify panel. This object already has a custom attribute to control the elbow swivel. You'll simply add another custom attribute to change the IK-FK weighting or blending. Press Alt-1 to access the Parameter Editor dialog. Name the new custom attribute IK-FK Blend. Set the width to 100 and leave the range from 0 to 100. A percentage value works well in this case. Set the justification to the right and add it to the modifier. Dismiss the dialog when done. You've learned to use the Reaction Manager before. This time, though, you'll use simple wiring to connect this custom attribute to the IK-FK weight values. Make sure the IK controller is still selected and go to the Parameter Wiring dialog, Alt-5 on the keyboard. You can also access it from the Animation menu. On the left pane, click the refresh icon to display the IK controller node. Expand and select the IK-FK Blend custom attribute. Now select one of the bones you want to control, such as the wrist bone. Click the refresh icon on the right pane. Expand Transform, Rotation, Orientation Constraint, and notice the two entries. The first entry is for the IK weight, the second for the FK weight. Start with the FK weight, the second in the list. It's easier to understand. Select Orientation Weight 1. At this point, you can select the IK controller in the viewport so you can see the custom attribute in the modified panel. The idea is to use an IK solution when the spinner reads 0 and an FK solution when the spinner reads 100. In other words, when the spinner reads 100, the FK weight should be 100 as well. If the spinner reads 0, the FK weight should be 0 as well. This means the spinner value and the FK weight should be the same. Set the control direction from left to right and click the Connect button. Now select the IK weight entry, Orientation Weight 0. As a side note, the 0 and 1 numbers are there to indicate the order in the list box. 0 is for the first item, in this case IK weight, and 1 is for the second item in the list, FK weight. The IK weight is a bit of a reverse value of the custom attribute. When the custom attribute value is 0, you are in full IK mode or 100% weight. When the custom attribute is at 100, you are in full FK mode and the IK weight should in turn be 0. Therefore, set the direction from left to right and set the formula to read 100 minus IK underscore FK underscore blend and click Connect. This will reverse the weight value and ensures IK and FK are always weighted to a sum value of 100. To repeat the procedure on the forearm, select the forearm bone and refresh the right pane in the wiring dialog. Repeat the steps you have just done with the wrist. Finally, repeat the procedure on the shoulder bone. When you're done, close the wiring dialog and make sure the IK controller is selected. Test the IK-FK blend custom attribute. You can now easily blend between one mode and another. Here's a handy little trick. You can instance the attribute holder modifier to the FK controllers. This can be done by holding Control while dragging the modifier to other objects. This way, you'll have access to the elbow swivel and IK-FK blend parameters no matter which ARM controller is selected. When you're done, select all ARM controllers and transform the selection back to 0 before moving on. Exit Isolate mode and save your file. In the next movie, you create custom attributes to control the status of both IK and FK chains in relation to each other.